Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, would you please switch on your camera? So everyone, please turn on your camera. All right. If your device is quite compatible, then I want you all to turn on your camera. Okay, we would like to start the lesson today. First of all, I'd like to thank you all, especially those who have submitted the assignment on 2 sample t-tests and ANOVA. For those who haven't submitted yet, I hope that after this class, everyone must submit the assignment. Today, we are going to discuss a new topic on simple regression. I hope you can see the screen now. Simple linear regression. Linear regression is looking at the relationship between two variables in a simple regression. One is the independent variable and the other is the dependent variable. Or the one is the predictor and the other is the criterion. Usually this analysis is used to find out the effect of the independent variable on the dependent variable while looking at the significant relationship between the two variables. This analysis may also be used to predict the dependent variable when we know the independent variable. If there is a change in the independent variable, then we can predict the change in the dependent variable. So this is a good way, especially in running business, for example. So every time we change the independent variable, then we expect to get some kind of result in the dependent variable. We can predict that. Okay, let's see some example for this here. Yeah, this is the example of relationship between two variables. If you still remember, when we do a scattergram, we'll have this kind of graph. Okay. The relationship between two variables. Remember that the horizontal line is the independent variable, or we call it predictor. And the vertical line is the dependent variable or the criterion. In some cases, they call it the response. Okay, the same, different name for the same variable. You remember that when we are doing a plot, scattergram like this, and the graph shows like this, it looks like there is a positive correlation between the two variables. When the independent variable is high, then dependent variable will also be high. Okay. They go in the same direction. So if the independent variable is low, and then the dependent variable will also be low. So the two variables goes in the same direction. you remember when the two variable goes in the opposite direction, we call it negative correlation. Okay, these are an example of a study that would try to see the effect of independent variable on the dependent variable. The relationship between the length of time of the machine damage and the product quality. So when the machine is damaged, and then how long it is damaged, and then we can predict that the product will be also damaged in how many, the volume of the product. Another example is the relationship between the number of workers and the production, the product output. Okay, so we maybe assume that the larger number of the workers, the more product will be result. Another one is the relationship between the temperature of the room and the defect products. So depending on the temperature of the room, then the product in that room may be predicted how many would be something like defect. Or another example here is the effect of the teacher performance on the student's motivation in learning, or student learning motivation. So these are examples of looking at the effect of the independent variable on the dependent variable. So here is the teacher's performance is the independent variable, and the student learning motivation is the dependent variable. In number 3, in this example, the independent variable is the room temperature, and the dependent variable is the defect products. Okay, so you now know the independent variable and the dependent variable, and now we are going to have some example, and then we'll work on that. Here is the formula for calculating the the regression. Y equals A plus bx. So y is the one that we predict, okay, the variable response, or the criterion, or the dependent variable. X here is the independent variable, the predictor, and A is constant, and B is the coefficient regression. So this the two that will be computed, how we find out the constant and how we find out the coefficient, regression coefficient. They usually call it slope, yeah, slope, the regression coefficient. Here is the formula to calculate the constant and the regression coefficient. To find out the constant, then you are already familiar with these symbols: the sum of y multiplied by sum of x squared minus sum of x multiplied by sum of sy, divided by n times sum of x squared minus sum of x squared. So these symbols are already familiar to you. So I'm sure that you will be able to do the computation later. To find out the regression coefficient, here is the formula: the n number, the sample size, times the sum of xy minus sum of x times sum of y, divided by n times x, sum of x squared minus sum of x squared. And it looks like very simple. Of course, when you have a set of data, then you can find out this formula, how to find out the criterion y by using this formula, A plus Bx. Okay, now let's see an example. So the step in calculating the regression formula is, first of all, we'll have the worksheet as usual, and then we'll have the score or the data on X and Y. And then we have to square X and square Y, and then you multiply X and Y, as usually when you are doing the correlation computation. And then after that, having the data on X square and Y square and X times Y, then you can start calculating the constant and the regression coefficient. And then after that, you will have the regression equation model. The regression equation model will be used to calculate whether we try to predict the dependent variable, or we'd like to have the independent variable. We can calculate that, or we can predict that. Here is an example. An engineer wants to find out the relationship between the temperature in a room and the number of product which is defect as the result of the temperature in the room temperature. By doing this, then we can actually predict the number of defect product if the room temperature is known, or if we can control the temperature in the room, then we can predict how many product will be defect. So here is it's very important for us to understand this, because the engineer wants to do that, then the engineer tries to observe for 1 month, 30 days, the temperature of the room in average every day, and then the number of product which is defect, and then we will understand the room temperature. The room temperature is the independent variable, and the predictor or dependent variable is the number of defect product. Okay. Let's see the result of the observation. So here is the record of the 30 days of the average room temperature every day. The first day, second day, the room temperature in average is 24 degrees Celsius, and the number of defect product is 10. So here is the independent variable, the average room temperature every day for 30 days. Okay, for 30 days. So now we would like to find out the constant and the regression coefficient. We would like to use the formula here, and then we have to find out in our worksheet what is the sum of x square and sum of y square and the sum of xy. So we have to find out using our worksheet. We'll square each of these temperature and the number of defect product. Okay, let's see. Here is the what is the worksheet. So you can see the worksheet from day 1 to day 30. This is the average temperature of the room, and here is the number of defect product for every day. And now we square every one of these, and here's the square of the temperature, and here is the square of the defect product, and here is the multiplication of the room temperature and the defect product. Okay, now let's see the sum of each. of this, we finally have the data that we can use in our formula. Here is the data. Sum of X is the room temperature is 699, and sum of Y, sum of the defect product is 282, and sum of X square is 1648.7, and sum of X square is sum of Y square is 3112, and sum of X multiplied by Y is 6861. By having this data, then we can now use the formula. Okay. To find out the constant, then you use this formula. We have the sum of Y, sum of X square. We also have the data on sum of X and sum of SY. So actually, we can just put the score that we have already calculated in our worksheet here. Okay. And then we'll have this. So sum of Y is 282, and sum of X square is 1348.7. Sum of X is 699, and then sum of XY, sum of XY, 6861. So we just put the number in this formula, and finally we have the result. The constant is minus 2438. Okay. So here is the constant, and then we calculate the regression coefficient using the formula, and every data we need for the formula is already here, so we can put all the number into the formula. And the number of observation is 30. Since the sum of XY 6861, sum of X is 699, and sum of Y is 282. Divided by N, number of observation 30, and sum of XY is 1648.7, and then sum of X square 699 square, and the result is 1.45. So now we have the, when you put this into the formula, Y equals A plus BX. So we have already A and B. So we can actually have the, what we call the regression equation model. Yeah. Next is we are going to calculate the correlation between X and Y using Pearson product moment. And I do not show here the process because you already know that. Use the Pearson product moment RXY. And then when you use the formula, you'll find out that the result is, the correlation coefficient is 0.96. So this is the RXY atau correlation coefficient. Next is we have already the regression equation model. Regression equation model is Y is minus 24.38 plus 1.45 times X. So X here, we don't know, depending on the data. Now, for example, if you want to predict how many defect products, if the room temperature is 30, if the room temperature 30, how many product will be defect? Okay. Now let's calculate that using our regression equation model. So we can put this data into our model, and then we know how many product will be defect. So we put this independent variable into the model X, and then we find this constant is minus 24.38 plus 145. This is the regression coefficient times the room temperature 30 degree, and then we have 19.12. This is the number of product which is expected to be defect when the temperature in average is 30. Okay. So we can predict when we know the temperature, then we can predict how many product will be defect, the number of defect product. On the other hand, we can also, so here is the conclusion. If the average temperature is 30 degrees, and then we can predict that there might be 19.12 units of our product will be defect. Okay, so we can predict that. How about we have another case? If you want that the defect product is only 4 units, what will be the room temperature? So we can also predict this. We can calculate that if I want the number of defect product is only 4, then I can put this into the formula, into the regression equation model. And what we have here is that we want 4. So this is the criterion, they predicted. We want 4 defective product, and then we would like to set the temperature. What is the average temperature should be? So we calculate this, and then we find out that the temperature should be 19.57 degree by using the formula. Okay, so 4 equals, so we just put the data into the model. 4 equals minus 24.38 plus 1.45x. So we don't know x, so x is put in the front. We put this in the front, and then we come 1.45x equals 4 plus 24.38. And now we put x over here to find out, and then we reverse this regression coefficient. Becomes 28 point divided by 145 equals 19.57. So that means that we can predict that if we want that the number of defective product is only 4 units, then the average temperature should be set to 19.57. Okay. Do you follow me? Does everyone understand what I have just explained? So regression is used to find out what is the effect of one variable on another variable, or the effect of independent variable on dependent variable, especially in prediction. So that's why usually this is called a predicted research. So here the sample is about the temperature in the room and the defective product. So it means that we can actually predict whether to set the temperature, or we need the average temperature in the room, or we need some, like we determine how many product we want to be defective. We say our example is if we need only 4, then we calculate what is the temperature will be by using the regression equation model that we have calculated. Okay, so far, if you have any comments, or if you don't understand or you're confused, you can raise your hand or you can ask. Okay. Anyone who wants to comment on this, or is it clear enough? If not, then we move on to the next issue about the regression. Now we would like to test the hypothesis whether this regression is significant or not, meaning that whether the effect of the room temperature is significant statistically on the number of defective product. Okay, so when we are going to test this hypothesis, then we have to convert the all the number that we have calculated into the t-test. We already calculate the B is the regression coefficient, and then the standard error, or you can also using the row score. What we have already calculated is the R. This is the correlation coefficient. If you remember the calculation for the RXY using Pearson product moment. So here is the formula to calculate the T observed, T statistic. R times square root of n minus 2 divided by square root 1 minus R square. So the data is already calculated, so we can calculate the T observed, the statistic of T. We have R, and we know the number of observation, and also we can square the correlation coefficient. In order that we can use this. You don't need to use the other formula because it's just the same. So now let's calculate that. So T equals R. R is 9.96 times square root of 30 minus 2. So 30 is the number of sample or number of observation divided by square root of 1 minus R square. So R square is correlation coefficient square, 0.96 square. And then what we have is 0.96 times 28. Okay. Should be square. Square root of 28. Square root of 1 minus 0.91. 0.96 square is 0.91. So equals 5.08 divided by square root of 0.09. And what we have is 5.8 divided by 0.3. Square root of 0.09 is 0.03 equals 16.93. So here is the T observed, T statistic. So if you remember the step to test the hypothesis, we use the steps again from starting from formulating the hypothesis until the statement of the decision. So here is the step stating the hypothesis, null hypothesis, and alternative hypothesis. There is no significant effect of the room temperature on defective product. Alternative hypothesis, there is significant effect of the room temperature on defect or the number of defective product. And then we select the alpha level, and then we select 0.05 as usual. And then we calculate the T. We already calculate that, and we have 16.93. Here is calculating the T. We already do that. And then find out the critical value from the T table with alpha 0.05 and degree of freedom 30 minus 1. 30 minus 2, sorry, so 28. So after finding out the critical value from the T table, then we can make a decision. If our T observed is greater than the value of the T table, then we reject the null hypothesis. Okay, this is the decision. So when we look at the step, then you find out the critical value from the T table with degree of freedom 28 and alpha 0.05 is 1.171. So that means that our calculated T is 16.93 or 16.93 is greater than the critical value from the T table, 1.171. So that means that there is a significant effect of the room temperature on the number of defective product. There is a significant effect of the room temperature on the defective product. Okay, is it clear? So actually there are two important aspects of this regression. The first one is to predict. That's very important to predict, as we have example here. Ya, kita bisa memprediksi andai kata temperatur ruangan itu 30 derajat, kira-kira berapa produk yang akan cacat. Nah, ternyata kalau kita masukkan di model persamaan regresi kita, maka kita akan menemukan bahwa jika temperaturnya 30, rata-rata 30, maka akan terdapat 19,12 produk yang cacat. Ini memprediksi. Nah, bisa juga kita memprediksi, ini contoh yang lain, kalau kita hanya menginginkan 4 produk yang cacat, berapa rata-rata temperatur pada ruangan itu. Nah, kita masukkan di model persamaan regresi kita akan menemukan bahwa jika menginginkan 4 unit jumlah produk yang cacat, maka rata-rata ruangan itu harus 19,57. Jadi bisa kita balik, kita memprediksi produknya atau memprediksi temperaturnya. Jadi kalau kita ingin yang cacat itu hanya 4 unit, berarti temperaturnya harus diset ke 19,57. Okay, so far is clear, or if you have any, if you are confused about this, you can comment or ask questions. Tidak ada yang ini ya, tidak ada yang membingungkan. Jadi regresi ini biasanya kalau pertanyaan penelitiannya itu, apakah ada efek? Nah, itu. Apakah ada efek variabel X terhadap variabel Y? Kalau misalnya, apakah ada efek jumlah buku yang dibaca terhadap penguasaan kosakata? Atau banyaknya jumlah kosakata yang dikuasai? Itu berarti efeknya, berarti nanti analisisnya regresi. Jadi bukan hanya hubungan, tetapi regresi. Nah, sehingga nanti bisa memprediksi kalau membaca buku sekian, maka jumlah kosakatanya bisa ditaksir, diprediksi sekian. Atau kita mengatakan jika ingin jumlah kosakatanya sekian yang dikuasai, maka harus membaca buku sekian. Itu kalau kita balik ya. Apakah variabel independen, prediktor yang mau diprediksi, atau variabel dependen atau kriterion yang mau diprediksi. Nah, itu. Kemudian kita lanjutkan dengan menguji hipotesis apakah efek itu signifikan atau tidak. Maka kita menghitung pertama correlation coefficient atau R menggunakan Pearson product moment. Kita akan mendapatkan R, kemudian kita masukkan pada rumus T. T hitung itu adalah R dikali dengan akar N kurang 2 dibagi dengan akar 1 dikurang akar N. Nah, nanti proses untuk menguji hipotesis ini sama dengan yang lain, mulai dari merumuskan hipotesis, menentukan level of significance atau alpha, kemudian menghitung statistik, nah itu tadi menggunakan rumus T, kemudian mencari nilai pada tabel T, mencari nilai pada tabel T dengan alpha 0,05 dengan degree of freedom N kurang 2. Baru kita mengambil keputusan jika T hitung kita itu lebih besar atau sama dengan yang di tabel, berarti H0 ditolak. Kalau T hitung itu lebih kecil dari yang di tabel, maka H0 diterima. Nah, itu. Ada pertanyaan? Ini tidak ada, berarti sudah Tahu. Okay, any questions or we move on? Oke, kalau sudah tidak ada masalah, saya akan coba untuk ini latihan. Latihannya, nah ini, coba ini kasusnya biaya produksi dengan volume penjualan. Jadi bisa nanti kita bisa memprediksi kalau ingin menjual sekian volume mobil, misalnya sekian mobil mau dijual, berapa biaya produksi. Atau sebaliknya kalau kita mengatakan, kalau ingin supaya kalau volume, kalau kita memberikan biaya promosi sekian, berapa kira-kira volume penjualan itu. Atau sebaliknya, kalau ingin volume penjualan sekian, berapa biaya iklan yang harus dikeluarkan. Jadi itu bisa kita hitung. Nah, inilah tugasnya untuk menghitung ini. Carilah model persamaan regresinya, the regression equation model. Kemudian kalau sudah dapatkan itu, maka ini Anda bisa, ini pertanyaan ada dua. Prediksikan berapa volume penjualan jika biaya promosi itu 19. Okay. Dan yang kedua, hitunglah atau prediksikan berapa biaya promosian jika menginginkan volume penjualan 68. Okay. Jadi yang pertama itu menghitung kalau kita mengeluarkan biaya iklan 19, maka volume penjualan berapa? Berdasarkan regresi model persamaan regresi yang kita sudah temukan. Sebaliknya kalau kita menginginkan penjualan 68, berapa biaya promosi yang harus dikeluarkan. Kemudian ujilah apakah ada pengaruh signifikan biaya promosi terhadap volume penjualan. Jadi 3 pertanyaan ini dengan data ini tolong dikerjakan. Nanti saya tunggu before midnight tonight ya. Sebelum tengah malam hari ini Anda sudah upload di grup. Ya silakan boleh di ini sebenarnya ada di Sam Oke, tapi kalau tidak boleh di screenshot datanya, kemudian ini pertanyaannya yang mau diselesaikan. Ada 3 yang ditanyakan, uji signifikan, apakah ada efek yang signifikan jumlah iklan atau jumlah iklan terhadap volume penjualan, dan yang kedua menghitung jika mengeluarkan biaya promosi 19, berapa volume penjualannya diperkirakan. Sebaliknya nomor ketiga itu jika menginginkan biaya penjualan itu sekian biji, sekian unit, berapa promosi yang harus dikeluarkan, biaya promosi yang harus dikeluarkan. Jadi 3 ini yang dijawab. Oke. This is not too difficult, it's quite easy anyway. Kalau tidak ada yang bertanya berarti everything is okay. Saya sedang menunggu saja. Before midnight, your assignment, your work on this problem should be submitted. Is it clear, everyone?
Yes, Prof.
Yeah,
Yes,
I will. This is easy. Everything is easy. Ingat bahwa pengenalan simbol-simbol dalam rumus itu sudah sangat familiar karena sudah mengerjakan tugas-tugas sebelumnya. Jadi saya kira tidak ada masalah. Baik. Kalau begitu kita akan akhiri pertemuan ini dan mudah-mudahan YouTube dari rekaman ini bisa saya sematkan juga di grup supaya bisa dilihat kembali kalau diperlukan. Saya kira itu. I'd like to thank you all for participating in this class. And I hope that everyone is able to do the assignment and submit before the the deadline, the due date. Before midnight tonight, everyone should already submit the exam. Thank you. Saya kira demikian, mudah-mudahan bermanfaat dan semuanya bisa dipahami. Silahkan mengerjakan masing-masing di luar dari pertemuan ini. Saya akan akhiri Zoom kita ini. Terima kasih banyak. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof.
Welcome.
Thank you, Prof.
Ini ada yang baru masuk, Indah Pratiwi. Nanti disampaikan kalau dia tidak dengar tadi ya. Saya akan usahakan sematkan rekamannya ini di grup. Thank you. I will end the meeting. Thank you very much once again.